Our lesson for today is on 2.4a, in which we're going to learn to multiply and divide numbers written in scientific notation. Now, in order to do that, what we want to do is we actually want to group the numbers that are 1 through 10 together, and then the powers together, and then perform the operation. Alright, so we want to group the front numbers together, excuse me, and group the powers together, and perform the operation. Now, this is what we're doing for multiplying and dividing. This is not necessarily what we're going to be doing for adding and subtracting. Now, with that, I realized that when we were first learning math, we learned to count first, and then we learned to do addition and subtraction next after that. And then later on, we learned how to multiply and divide. With scientific notation, I think it's actually easier to multiply and divide than it is to add and subtract. So that's why we're starting with multiplying and dividing. Tomorrow or the next day, we'll get to adding and subtracting numbers in scientific notation. But let's go ahead and take a look at a couple examples to see how this is done. So for our first example, it's a multiplication problem. We have 1.8 times 10 to the 9th times 6.7 times 10 to the 12th. So what I said before about grouping the front numbers together and grouping the powers together is going to look like this. Really what we have in this problem is we have four things that are being multiplied together. We have 1.8 times 10 to the 9th times 6.7 times 10 to the 12th. And I'm going to rearrange the order in which those things are being multiplied. So I'm going to rearrange this to look like 1.8 times 6.7, and then multiply that by 10 to the 9th times 10 to the 12th. Okay? Now 1.8 times 6.7 is going to give us 12.06. Then we're going to multiply that by 10. And now to get our exponent, 10 to the 9th times 10 to the 12th, we're multiplying powers with the same base, so that means we add the exponents. So 9 plus 12 is going to give us 21. Okay? So we've gone ahead, we've multiplied the numbers in front, we got 12.06, we multiplied the powers and got 10 to the 21st. However, when we look at this answer, there's something wrong with that. In order to be in correct scientific notation, we need to have a single digit number in front of the decimal. Right now we have a 2-digit number in front of the decimal. So I need to move my decimal place in order to make this an appropriate answer. Okay? So I'm going to move my decimal place. Use a different color. Move my decimal place to in between the 1 and the 2, giving me 1.206 times 10. Now, the exponent is going to change when we move our decimal place. And we're asking ourselves, if I make my purple number smaller, I go from 12.06 to 1.206. That makes my answer in front smaller. My number in front is getting smaller, so that means my exponent has to be bigger. We can think of it kind of like a teeter-totter or a seesaw. The number in front gets smaller, so the exponent has to get bigger. Since I make one ocean wave, I increase my exponent by 2, becoming 10 to the 22nd power. Okay? Let's take a look at another one of those. For our next example, we have 5 times 10 to the 8th being multiplied by 3.8 times 10 to the 6th. So I'm going to rewrite or rearrange the order in which everything's being multiplied together. So I have 5 times 3.8. That's being multiplied by 10 to the 8th times 10 to the 6th. So now I have to go ahead and do some multiplication. When I multiply 5 times 3.8, I get 19 exactly, times 10. Now 8 plus 6, I add my exponents here. 8 plus 6 is going to give me 14. But again, that is not okay scientific notation. I need, my decimal point is right behind the 9. I need to move my decimal place up to where it's behind the 1, between the 1 and the 9. So I have 1.9 times 10, and if I make my front number smaller, so I go from 19 to 1.9, I make my front number smaller, so that means I need to make my exponent bigger. So I have 10 to the 15th power. Okay? So 1.9 times 10 to the 15th is our answer for example 2. Now let's go ahead and take a look at a couple division problems. For example 3, our first division problem, We had 3.46 times 10 to the 17th over 2 times 10 to the 15th. Now we're still going to group our numbers in front together and our powers together as well. And we're going to group those into two separate fractions. So I'm going to split that one fraction into two. I'm going to take 3.46 over 2 times 10 to the 17th over 10 to the 5th. Okay? Now I'm going to do my division. First I take 3.46 and divide it by 2. And I get 1.73. Multiply that by 10. Now when I'm dividing powers with the same base, 17 and 5, I subtract the exponents. Since I'm dividing, 17 minus 5 gives me 12. I look at my answer to make sure that it's in correct scientific notation, and it is because I have a single digit number in front of the decimal, so I'm all done. I have 1.73 times 10 to the 12th power. Let's take a look at one more example. For this one, we have 4.2 times 10 to the 18th over 5.6 times 10 to the 11th. Again, I'm going to group the like terms together. So I'm going to take 4.2 over 5.6, multiply that by 10 to the 18th over 10 to the 11th. All right. First, I take 4.2 and divide it by 5.6. That's going to give me 0.75. Then multiply that by 10. Again, I'm dividing powers with the same base, so that means I subtract the exponents. 18 minus 11 is going to give me 7. Okay? I look at my answer to make sure it's in correct scientific notation. Problem here is that it is not. I do not have a single digit number in front of the decimal, and I need to have one there. So I need to move my decimal back to in between the 7 and the 5. So now I have 7.5. I've made my number in front bigger. I've gone from 0.75 to 7.5. I've made my front number bigger. That means I need to make my exponent smaller. So I have 7.5 times 10 to the 6th power. All right, for our last example, it's a word problem. It says, when the sun makes an orbit around the center of the Milky Way, it travels at 2.025 times 10 to the 14th kilometers. That's how far it actually has to travel. Okay, so the orbit of the sun around the Milky Way is 2.025 times 10 to the 14th kilometer. That's the distance that it actually has to travel. Now the orbit takes 225 million years. So it takes 225 million years for the sun to orbit once around the center of the Milky Way galaxy. At what rate does the sun travel? Write your answer in scientific notation. So in order for us to do this one, we first need to understand that the rate is going to be equal to distance over time. Okay? Rate is equal to distance over time. So our distance we have as 2.025 times 10 to the 14th kilometers. Our time is 225 million years. So what I'm going to do is I'm going to actually write that out. I'm going to write it in the upper right hand corner kind of. And then I'm going to rewrite it so that it's in scientific notation, so that both of our values are in scientific notation. So 225 million is going to look like that. Okay? Now in order to write this in scientific notation, I'm going to make ocean waves from where our decimal is to where we want it to be. And I end up with 2.25 times 10 to the 8th power. Alright? So, distance is 2.025 times 10 to the 14th. Time is 2.25 times 10 to the 8th. And that is years. So R for rate is going to be equal to 2.025 times 10 to the 14th over 2.25, times 10, come on now, times 10 to the 8th. I'm going to kind of draw a dividing line. I know I tell you guys not to do this, but I'm running out of space, so we'll bring our work up here and say R is equal to 2.025 over 2.25 times 10 to the 14th over 10 to the 8th. And now when I do that, I get R is equal to 2.025 divided by 2.25 is actually 0.9, and then times 10, 14 minus 8 is going to give us 6. Alright? Now, I look at my answer. That is not okay scientific notation. I need a single digit number in front of the decimal. So I'm going to move my decimal back here. And I get R is equal to 9 times 10. Because I made my number in front bigger, I went from 0.9 to 9. I need to make my exponent smaller. So I have 9 times 10 to the 5th. And our label for that is going to be kilometers per year. Okay, sorry about how messy that got at the end. Our rate, again, is 9 times 10 to the 5th kilometers per year. All right, so that's how fast the sun is traveling around the center of the Milky Way galaxy. All right, write down any questions that you have, and we will talk about those in class.